Hi, welcome to the flipped instructional session for Math 08B for Unit 210 on polygons. Our objectives today are determine whether a figure is a polygon, to classify a polygon by its number of sides, to classify a polygon as regular, equiangular, equilateral, or none of these, and to finally use equations to find polygon angle measures and side lengths. As with all of geometry, the definitions are important. So let's first talk about what a polygon is. It's a closed figure formed by 3 or more lines such that each line intersects exactly 2 other line segments at the endpoints only. The sides of a polygon are the line segments. The vertices are the points where they meet. So let's just draw one right here. So here's a polygon. Each line segment only hits 2 other line segments. So here is a side. The point where they meet, so this point right here is the vertex. A regular polygon is a polygon with all its sides congruent and all its angles congruent. So I'll try to draw one. So a square has equal sides and equal angles. A rectangle does not have equal sides, although it does have equal angles. So this one is regular. This is non-regular. So we've talked about polygon, regular, sides, vertices, okay? Equilateral is a polygon with all sides congruent. So this is equilateral because all these sides are congruent. This is equilateral. Equiangular is a polygon with all angles congruent. So this is equiangular as well, which is harder to spell than I thought it would be. This is also equiangular because the angles are the same. So those are equiangular and equilateral. Equilateral is talking about the sides. Equiangular is talking about the angles. What is the area of this polygon? And so we can look at this and see we have 3 different shapes that we can break this down into. We have a rectangle right here. Let me highlight that. We have a right triangle here. And then we have another right triangle over here. So we can find the area of those 3 separate and add them together. So let's look at this right triangle over here. So a triangle, to find the area, is 1/2 base times height. That's for a triangle. The area of the rectangle is just base times height, or length times width. So let's look at this first triangle. We would have 1/2 15.3 times 3 plus the area of this rectangle, which is 33 times 15, length times width, or just base times height, plus this other triangle, 1/2 base 8 times height. Now, I just realized when I did base times height here that I messed up this 1/2 base times height. So 1/2 times 3, that's the base. The height of this triangle is this right here. Here's the height. You want to use the straight up and down. So instead of 15.3, this should just be 15. So 1/2 the base times the height. You want those two, the base and the height should make a 90-degree angle. So that's why over here I have base times the height. So the height of each of these is 15. So I did not need these numbers when calculating the area. So if we add up in our calculator, 1/2 times 15 plus 3, and then do, so let's see, 1/2 times 15 times 3 is 22.5. So I'm going to write 22.5 plus 33 times 15 is 495. And then 1/2 times 8 times 15 is 60. So when I add these together, I get 577.5. It's meters squared because we're talking about area. Meters times meters is meters squared, so it's important to have a unit squared here. Is this figure a polygon? So we know it's a circle. It certainly is a shape, but let's look at our definition of polygon again. Polygon is a closed figure formed by 3 or more line segments. This is formed, I guess, really by no line segments. It's really just one continuous. So this is not a polygon. The smallest polygon, 3 or more line segments, is a triangle. So circle, not a polygon. So let's name, or let's match. We have hexagon, octagon, and quadrilateral. So something that I always tell people to remember, a hexagon, because people get hexagon and pentagon confused. But a hexagon has an X, just like 6 has an X. So hexagon has 6 sides. Octagon has 8 sides. And quadrilateral, quad means 4. So quadrilateral has 4 sides. So again, not necessarily difficult math-wise, but knowing all of the definitions is the challenge in this unit. A regular pentagon. So we just talked about a hexagon has 6. A pentagon has 5 sides. So a regular pentagon has a perimeter of 10 meters. What is the length of each side? So if we have, and it says the perimeter, we add up all of these sides, x plus x plus x plus x plus x, equals 10. Notice this is meters, because when we add units, we just keep the meters. Remember, meters squared was the area when we multiplied. So we have 5x, because there are 5 sides, 5x equals 10. So the length of each side, we just use simple algebra, divide both sides by 5. X equals 2 meters per side. And we can check that, 2, 4, 6, 8, 10. 2 meters per side. Does the figure appear? Oh, one thing I should have mentioned. This says regular pentagon. And remember, regular means the sides have the same length and the angles have the same measurement. So that's how I knew each side was X, because they all have the same length. All right, does the figure appear to be a regular polygon? Do the sides look the same? And do the angles look the same? I think yes. They're not going to be super tricky. So if it looks like it, then it is. Thanks for watching. Please come to the flipped follow-up session or the help session, which you can find on your Class Connect schedule should you have any more questions over this material. Thanks.